Okay, hi and welcome to Video Notes 5.2, which is on functions and relations. Really, if we want to get down to it, this is the heartbeat of algebra. This is the heart of algebra. The main core thing that we need to get out of algebra starts here. Really, it's kind of everything in this unit, and we'll see it play out through all of the rest of the units. So if we can get really good at this, everything else we look at, we'll have a little understanding already going in. So, what is the main heartbeat of algebra? And that is, my friends, what is a function? That's really what we're after here. Our understanding of what a function is, and to understand a function, we'll need to know what a relation is. And then I'm going to show you that, and we're going to explore them kind of generally, what functions are, get an understanding of how they work and what they are, because I'm sure you've heard the term, but maybe you don't understand everything that's related there. So we'll get that cleared up today. So let's go ahead and start chatting about this. So to understand a function, let's talk about a relation. Not a relationship, not like a friend relationship. Hey, I got a buddy, it's my friend. Not quite like that. A relation for us, simply said, is a pattern. A pattern of something that occurs, something we can count on, something that doesn't occur, but some form of a pattern is what we're looking at. So right now we're going to call everything kind of a relation. And if I slip and say function, I apologize, because in algebra, we tend to focus on functions. So already you're getting an idea that there's a difference between a relation and a function. And there's a key difference. All right, so let's move down here. Let's talk about how to define a function first, and then we'll start talking about this relation to help us understand better what that function is. So to understand what a function is, in high school, I was told it was a toaster. Never understood why it was a toaster. I didn't understand what the bread was. I didn't understand what the toast was. So I'm going to try the same thing, but I'm going to do it a little bit different for you. So you have your toaster story when you get older. All right, what I'm going to call a function is I'm going to call it a vending machine. So you see my giant purple vending machine here. And you'll notice there's the big purple outline box, and here are where all the snacks are contained. These are the numbers that you would press to get those particular snacks. These ones are empty because Mr. Hallam got a little lazy and didn't fill them in. But over here you can see are the buttons that you would press to tell the machine which snack you wanted out. Okay, so if the vending machine's the function, let's talk about the parts of the function that we can work with or deal with or determine what snacks we're getting, shall we say. So to be able to figure out what snack I want out of the vending machine, I have to have a button pressing. So I have to push some buttons here. See, I got to press buttons to tell it what snack it is. So I'm going to put into the function what I call, appropriately named, inputs. Inputs are the values that go into the function, right? So if I draw back out of the vending machine, it's not just button pressing. These are values, variables, things that go into the function, and then they produce what would come out, which would be the snacks, or we'd call them outputs. Okay, so inputs go into a function and they come out as outputs. For us from the vending machine, I press a button and an output comes out, and that's a snack. Inputs go in, outputs come out. See why I'm using a vending machine? Kind of makes sense. So if we look at this particular vending machine, let's just take a minute to check it out. We'll notice that up here, NCD stands for nacho cheese Doritos. CRD stands for Cool Ranch Doritos. Pretzels are pretzels. Hey, we got another bag or row of nacho cheese Doritos. Maybe we got some form of cookies. Then we got some Pop-Tarts. Everybody loves a good Pop-Tart. So we'll pretend that's all filled up. So our vending machine, let's practice this. This is our function. We would put something into it, some button combination. So let's press A1, and A1 is going to correspond to this. The vending machine is going to go brr, 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 and nacho cheese Doritos are going to drop to the ground. That's what a function does. Put something in, something comes out. Okay, and if I press some different button combination, then I should get something different out. So if I press A2 this time, I should get whatever's corresponding to A2. So I put an input in, I get the corresponding output, or snacks in this case, of Cool Ranch Doritos. Those drop down to the bottom. Okay, what never happens or shouldn't happen in vending machine is that I press some button combination like, I don't know, A3. I'm looking for pretzels this time. I'm going to press A3 and a Snickers pops out, or a Tootsie Roll bag pops out, or Reese's Pieces pops out. If I press the vending machine combination of buttons and it doesn't give me what's located right there in the window that I could see, I'm going to be pretty upset. I'm going to say that's a terrible vending machine. I was really looking forward to some pretzels. I was watching my weight. I didn't need a Snickers bar. Thank you very much, machine. What are you trying to tell me? So at that point, you're not going to go back to that vending machine, and then you would be done with it. So that kind of makes sense. Now notice here really quickly that we can have some duplicates of stuff that may be important here in a minute. Because what I want you to do is I want you to scroll down here and I want you to pause the video and I want to see if you can answer some of these questions. And then we'll come back and talk about them. So go ahead and do that now. Okay, so you've had a minute to answer those questions. Let's look at what I've got here and let's chit chat about it just a little bit. Again, these all regard the vending machine. So it says, will an input, some button combination, let's throw down a B there just so we know what that means, of ever have more than one output or snack? Well, oops, really, unless something goes wrong, no, it shouldn't. Every button or combination of buttons corresponds to exactly one snack in the machine. The only time that would happen is if like there was two bags, you know how they like get caught up and the last guy didn't get his snacks, but they were together and you might get really, really lucky. But we're going to ignore that. So no, really, for a vending machine or a function for us, every input should have exactly one output, one unique output. And that's a big piece we need to make sure that we know. Okay. Will an output ever have more than one input? So will a snack ever have more than one button combination? Well, yeah, notice I drew your attention to the fact that there was two locations for nacho cheese Doritos. If I hit A1, I'm going to get nacho cheese Doritos. And if I hit B1, I will also get nacho cheese Doritos. That's okay. That's fine. So your function can have repeat values. Really, it could be a really boring function or a boring vending machine. It could be nacho cheese Doritos in every column, and you knew exactly the only thing that would come out of that was nacho cheese Doritos. It's really boring. We probably wouldn't talk about it if it was an actual function in algebra because it just did one thing. We like to talk about the ones that do different things. But so that is true. We could have snacks in a vending machine at two locations, so or two or more, and that's fine. You can have more than one output coming out of a function. All right, so then we've already said this a few times. What variable in math represents the inputs? And we said that that's x, but it's also important to throw in another term in there. We'll call that the independent variable. Let's talk about that in a second after we answer the next question. What variable in math represents the outputs or the snacks, right? Well, that would be our y. And so right now you're starting to drift into this feature here, which is what we would refer to as a function. And you'll notice I have f of x. I wanted to introduce that early. You're used to seeing y there. They're going to end up being the same thing. So here it says y, and we're going to add a little f of x over here for our notes. We'll talk more about that in about 2 days. All right, so looking at this, y is our outputs, x is our inputs. So let's label it. Here's our inputs. Here's our outputs, just so you can see what it is related to in algebra, because now we're trying to translate this vending machine. Inputs here, a button combination, we put things in for x, and then things come out, or your snacks come out of y after something happens. So that's where the vending machine comes in to make sense. We put things in for variables, and outputs come out, and it tells us what's unique spot that happens to be. And like we said before, for this to actually be considered a function, and not a relation, so relation is a pattern, a function has to have each input go to exactly one snack. If something comes out that we don't expect, that doesn't work, and we're like, wait, what happened? We don't call that a function. And then we don't really deal too much with those in algebra. We'd like to focus on functions. So back to my last little point was independent and dependent variables. And you should remember those from science, but just to remember, if you think about pressing the button, who's in control of what snack comes out of a function? Is it the button press, or is it the snack falls out that determines your buttons? That's how I like to do it. I'll do that in class so it makes a little more sense. But the independent variable then is the one that you can control. The dependent is what comes out after you do something. So these are the button presses, which determines the snacks, or the snacks depend on the button pressing. So what occurs if there are two outputs for one input, meaning that we have a bad vending machine, meaning that we pressed a button combination and we didn't get what we want? Well, we'd call that a terrible vending machine, which is not a function. It just falls under the fact that it's a relation. So relations are the very general form that there's a pattern, there's something going on, but a function is the specific one, meaning that every time I put something in, a very specific thing comes out and I expect that specific thing. So that's the difference between functions and relations.